Okay, so let's kind of look at the opposite of what we were doing in the previous units and look at factoring. So when I say opposite, previously we were multiplying out polynomials. Factoring is kind of doing the opposite. It means just to write as factors. And y'all probably have seen the word factors before, but we should define it. Factors is just things being multiplied. So as I said, you should have seen it before in algebra class, or at least in a number class, so 3rd grade. You've probably seen it in something called prime factorization. Prime factorization means to factor a number into its primes. Primes being something can only multiply by itself in 1. So it'll be divided by itself in 1. So if I'm going to write this as a prime factorization, it's the factor tree. Again, another word you may have heard or term. So 2 would go into 60, and when we're factoring, since we're writing it as stuff being multiplied, we're dividing. We're saying 2 times what gives me 60? Well, that's the same thing as 60 divided by 2 is 30. So when you factor, we're seeing what divides into everything. 30, I can keep going. 2 would go into that 15 times. 2 is prime and 2 is prime, so I can't break those down anymore. But 15, I can keep going to 3. 15 divided by 3 is 5, meaning 3 times 5 would give me the 15. So these are my factors. 2 times 2 times 3 times 5, or, more simply, 2 squared times 3 times 5 would be the prime factorization of 60. So when we factor, we want to write as stuff being multiplied, which means we want to see what divides into everything. So let's start off. If I have the first one, something like 2x squared y cubed minus 8x to the 4th y plus 12x to the 7y to the 7, and I want to factor it, I want to write it as things being multiplied. So I'm going to write a big parentheses, because I know when I'm working with polynomials, parentheses means multiply. Okay, and to write as things being multiplied, I have to see what divides into each term. So I want to see, and I'm going to write little fraction bars right here. Fraction means divided. I'm going to see what divides evenly into everything. So let's see, between my numbers, 2, 8, and 12, I know 2 divides into all of them. So I know that one of my factors is going to be a 2. So I'm going to write the 2 on the outside of the parentheses. Again, I want to write it as stuff being multiplied. So I'm going to have a 2 on the outside of the parentheses. And on the inside, I'm going to write whatever 2 would multiply to give me my numbers. Again, we just do this by dividing, so 2 over 2 is 1, minus 8 over 2 is 4, plus 12 over 2 is 6. Okay, so the numbers are pretty done. Let's look at my variables. I have x squared, x to the 4, and x to the 7. So I can start off by saying, well, could I divide an x out of everything? And if I look at this, I know when I divide common bases, I subtract the exponents. So yeah, I could definitely divide out 1x. That would go in evenly. If you notice over here with the prime factorization, wanted to make sure it went in even. We didn't say 7 into 60, because then I had a fraction. So we're always trying not to end up with a fraction. Okay, so instead of just 1x though, what would happen if I tried to divide by x squared? Would that still go in evenly? If I write that out, it will. X squared over x squared would cancel out, so that would be fine. X to the 4 over x squared would be x squared, and x to the 7 over x squared would be x to the 5th, so it still goes in evenly. What if I tried x cubed? I can't have x cubed because x squared over x cubed would give me a fraction. My largest exponent would be on the bottom. So I have to stop at x squared. Okay, so we already did this. X squared over x squared canceled. X to the 4 over x squared was x squared. And x to the 7 over x squared was x to the 5th. Okay? So I can see how many y's I can divide out. I can definitely divide out 1y. So that works, and I don't end up with a fraction. Everything goes in evenly. I can't do 2 y's. My second term there, this y, if I tried to do 2 y's down here, I'd end up with a fraction. So the little trick is whenever we're factoring out variables, it's always going to be the lowest exponent that you have. So with my x's, my lowest exponent was x squared. With my y's, my lowest exponent was y. So let's see, y cubed over y was y squared, y over y canceled, y to the 7 over y was y to the 6. And this is it. I do want to check two things before I go ahead and circle my answer. I want to check and make sure nothing else can come out of my parentheses, and it can't, and I want to go ahead and multiply it back in and make sure I factored it correctly. We'll do that with the next one. Okay, so let's look at the next one. 10x to the 4th, y to the 8, plus 5x cubed, y to the 6, minus 15x to the 6, y to the 4. Again, I want to factor, so I'm going to write it as parentheses. I'm going to see what I can put on the outside of what divides into every single term. So my numbers, 10, 5, and 15. 5 would divide into every single one of them. I'm not going to write the fraction this time. I'm just going to go ahead and do the division in my head. So 10 divided by 5 would be 2. 5 divided by 5 would be plus 1. Minus 15 divided by 5 would be minus 3. Okay, so I'm going to try the next thing and move on to my x's. X to the 4, x cubed, and x to the 6. So my smallest exponent is x cubed, so I'm going to divide that out. So I'm going to write x cubed on the outside because I'm factoring it out. X to the 4 divided by x cubed would be x. X cubed divided by x cubed would cancel. X to the 6 divided by x cubed would be x cubed. Okay, my y's, y to the 8, y to the 6, and y to the 4. So again, I'm going to divide out the smallest. So I'm going to divide out a y to the 4. Write that out as a factor. So y to the 8 divided by y to the 4, y to the 4. Y to the 6 divided by y to the 4, y squared. And y to the 4 divided by y 4 cancels. So again, I want to look at my parentheses, make sure nothing else can come out. Between 2, 1, and 3, only thing that can come out is a 1. Dividing or factoring by 1 doesn't change anything. Between x, no x, and x cubed, I can't pull out an x. There's no way I could divide that second term by an x. Same thing with my y's. Y to the 4, y squared, and the last term, no y's. I couldn't divide out a y. Okay, so the other way to check, you should always check both, is to multiply it back through and make sure you get what you started with. So if I multiply back through, 5 times 2 is 10, x cubed times x is x to the 4, y4 is y to the 8. Next term, 5 times 1 is 5, x cubed times, 1 is x cubed, y to the 4 times y squared is y to the 6. Last term, 5 times minus 3 is minus 15, x cubed times x cubed is x to the 6, y to the 4 times 1, or blank space, is just going to be my y to the 4. That is what I started with. So this should be the right answer. I can go ahead and circle it now. Okay, let's try the next one. 2x to the 8, y to the 4, minus 3x to the 6, y to 9, plus 4x to the 5th. Again, I'm going to want to factor, so I'm going to write as multiple. So I'm going to write in parentheses. I'm going to see what I can pull out or what I can factor out. So my numbers, 2, 3, and 4. Nothing but 1 divides into them, so I can't pull out any of my numbers, so I have to keep it as 2 minus 3 plus 4. My x's, x to the 8, x to the 6, and x to the 5th. My lowest x is going to be x to the 5th, so I'm going to factor that out. When I factor that out, x to the 8 divided by x to the 5th would give me x cubed. X to the 6 divided by x to the 5th would give me x. X to the 5th divided by x to the 5th would cancel out. Okay, my y's. Y to the 4, y to the 9, and no y's. So my smallest is my no y's. So I can't pull anything out. So I just have to keep my y to the 4 where it is, and my y to the 9 where it is. Again, check, make sure nothing else can come out, and multiply back in to make sure you factored it correctly. This one is, so we're set. It was kind of a weird factorization. We could only pull out one thing, but it's still factored. Okay, let's move to the next one. 6x squared y minus 3x plus 18x to the fifth y cubed. Again, I'm factoring, so I'm going to write a big parentheses. I'm going to see what I can pull out first so I can do it all in one turn. Okay, so my numbers, 6, 3, and 18. 3 is going to come out. My x's, x squared, x, and x to the fifth. Smallest exponent is x, so I'm going to factor that out. My y's, y, no y, y to the 8. No, that's y cubed, sorry, y cubed. Again, smallest is my no y, so I can't pull out any y's. My y's just have to stay where they are. Okay, so I'm going to factor out this 3x, which means I'm going to divide that 3x out. So 6 divided by 3 is 2. X squared divided by x is x. My y is still there. Second term, 3 divided by 3 is 1. X divided by x cancels out. And I had no y, so just minus 1. Next one, 18 divided by 3 is 6. X to the fifth divided by x is x to the 4. And no y's came out, so my y's are just there. Again, check. But I got faith, that one should be right. Alright, let's try the next one. So 6x to 7 minus 11x to 11y plus 9y cubed. So I'm going to start off again, I want to factor. So I'm going to write a parentheses. Look at my numbers. 6, 11, and 9. Nothing can come out. X is 7, x to 11, no x's. So I can't pull out any x's, so I have no x's here. No y's, y, y cubed. Same thing, I can't pull out any y's, so I can't pull out anything. So this can have two answers. This can be called not factorable, because I can't factor it. So that's sometimes shortened to NF. It can also be called prime. When I have something I can't factor, like if I was trying to find a prime factorization of 11, I couldn't. 11 itself is just prime. So I can call this prime. Either one doesn't really matter. Hey, let's look at the next one. Say I have 3x plus 6y plus 18. So again, I want to factor, so I'm going to write a parentheses. My numbers, 3, 6, and 18. 3 can come out. My x's, x, no x, no x, so no x can come out. My y's, no y, y, no y, so no y's can come out. So only thing I can pull out is my 3. So 3 divided by 3 is 1, x is still there. 6 divided by 3 is 2, y is still there. 18 divided by 3 is 6. That's it. Let's try the last two. Next one should be pretty straightforward, so I'm going to factor, write a big parentheses. 12, 8, and 4. 4 is going to come out. X to the fifth, x cubed, and x. X is my lowest, so that's going to come out. Y squared, and y to the 7. Y is my lowest, so that's going to come out. Okay, so if I divide, 12 divided by 4 is 3. X to the fifth divided by x is x to the 4. Y came out. So 8 divided by 4 is 2. X cubed divided by x is x squared. Y squared divided by y is y. Last term, minus 4 divided by 4 is minus 1. X divided by x cancels out. Y to 7 divided by y is y to 6. That's it. So let's look at the last one. Even though this is pretty screwy, I can still factor it. It's only two terms. The little weird symbol right there is a gamma, the Greek letter. So we have 3 gamma square, parentheses, n minus 3, close parentheses, 2, or squared. Plus 12 gamma to the 4th, square to the 5th, times that binomial, the parentheses, n minus 3. So I'm going to look at each term and see what can come out of each term. So I'm going to write a big parentheses. In fact, since we have multiple parentheses in here, I'm going to change my parentheses to a bracket. Okay, so between 12 and 3, 3 can come out. So I'm going to write a 3 on the outside of that bracket. Between gamma and gamma to the 4th, gamma would be my lowest, so that can come out. Between square and square to the 5th, square is my lowest, so that can come out. Between m minus 3, that binomial squared, and m minus 3, that m minus 3 not squared to 1 would be the lowest, so that can come out. I'm going to keep it as a binomial, so keep the parentheses. And now I just need to see what's left in each term. So my first term, 3 divided by 3 is 1. Gamma divided by gamma, canceled. Square divided by square, canceled. M minus 3 squared, if I divide that by one of them, I'm just going to be left with m minus 3. Okay, second term, 12 divided by 3 would be 4. Gamma to the 4th divided by gamma would be gamma to the 3rd. Square to the 5th divided by square would be square to the 4. M minus 3 divided by m minus 3 will cancel. That's it. This is factors. So even if you get symbols that you've not seen, you should be able to still follow the same steps.